Hello guys, today I want to talk about the events from a slightly different perspective. I'm gonna show you on the mind map. So I want to talk not only about the events but about the general structure of the application, of the software application. So generally speaking, when we start talking about the application, I usually imagine space station. This is what comes to my mind when we start speaking about the application, because the application consists by independent modules. As you can see here, each one of the modules could exist absolutely independently from the entire structure. This is how the application actually should be built. This is in my mind, as I said. And each module on its turn actually consists by independent smaller modules. And each one of those modules consists by independent modules which are even smaller, and so on and so forth, in both directions, up and down. If we can build such structure with our software tools, then I think we will have the perfect application. Each module should be absolutely independent, strong cohesion and loosely coupling. And this could be done through Event Manager, I think. I call it Event Manager because this is the most familiar right now talking about Zen framework, but I would call it differently. I would call it environment. What actually allows us to connect the modules like that and at the same time keep them totally separated. It's a very abstract matter. I will show you just a little bit examples, because there are a lot of reading in the internet which you can find. For example, Matthew from the Zen framework team was talking about the event manager, and many other authors. I want to abstract this topic. Nikola Zakas actually was talking about how to build our applications without showing too much code. So I would do something similar. Nikola Zakas, when he was talking about the structure of the application, about the architecture of the applications, was using the sandbox and the kids which are playing in the sandbox as an analogy. So I'm using a space station. So Nikola Zakas said that for him the application is like a kids playing in the sandbox. The kids was told, don't speak to strangers, so speak only to your parents, just to emphasize the fact that the modules of the application shouldn't talk to each other, they should talk through something, a provider. But I have a slightly different view of that. So it's partially true. For example, this module doesn't connect directly to this module. The connection can be done only through the parent module. The signals go only through the main module. Yes, but it's possible to be connected like that. If this module doesn't exist, for example, for some reason, we're able to connect these two modules, and these two modules, or even only one of them, could become a core of a new system. Why not? How can we build such structure? In our environment, we can see such things everywhere. Even the human body is like that. We are built from modules. We are built from independent cells. The cells create clusters, muscles, bones, and they're relatively independent. Okay, so if we want to build such thing and mimic this behavior and this structure, we have to use something which allows us to send signals from one module to another module. And this could be the event manager. We could call this environment an event manager, but I will use probably in this lesson, yeah, I'm gonna use event manager, but think about that mostly like a connection, mostly like environment that allows us to send signals and to receive signals. We can listen through this environment, exactly like the air. We won't hear each other if there is no air, because there is no environment. There is no event manager. If you wanna call the air somehow, in our word, in this case we would call it event manager. This is what the event manager does actually. It allows the different modules to communicate to each other. Air could be called event manager when we speak, when we say that our signals actually get transferred through the air as a sound. Okay, so this is how I think about the application, and this is what the event manager actually is. For me, the event manager is environment which allows me to send signals and listen for other signals coming from other modules. When the module actually connects to another module, what we need is to exchange an environment, a wire if you want to call it this way, or bus, talking about the computers, or something which allows us to send signals and listen for signals. That's all. And because in the software we can create virtual objects, of course we can create such environment. I like to think about the event manager as a bus. If we go to the electronic circuitry, to the theory of the motherboards, for example, it's like a data bus or address bus. This is what we provide, this is what we mimic and model actually using our object-oriented tools. With object-oriented programming we can build such environment which allows us to send signals. This is the essence for me for the event manager. And each module when connects another module, they should exchange, as I said, event manager actually not exchange, is always from one direction, from the central module. It goes from the central module to the new module. What the central module should do is just create one object, which is the event, and pass to this module. Now the central module sending this module, sending the event listener, the event manager can listen for certain events which are happening in this module, and vice versa. They could be a central event manager, as we do have in Zen Framework 2 actually, which also can be passed to the new module, and it is global. It is global, and in Zen Framework 2 we just can listen about the events happening in this central environment, if you want to call it this way. So this is a little bit abstract, but this is how I think about the applications. Okay, so what I can say about this module is that it consists by independent modules. This is exactly what we are aiming when we try to create a good software architecture. We want our application to be a constellation, a group of independent as possible modules which communicate between each other and create the application. Each module is built from a group of smaller modules following the same pattern. Actually, each one of those modules actually consists of smaller modules, and those smaller modules consist of even smaller modules following the same principle, following the same pattern. This would allow us to build incredibly complex systems. The smaller modules, as I said, are built from even smaller modules following the same pattern, and so on and so forth in both directions. Each module can trigger an event. Each module can trigger one event, but there may be modules listening on this channel. For example, for this event, we can call the event a channel. The name of the event we can call channel. Or maybe not. But this is not gonna break the system. So if a module triggers an event and nobody is listening, that's okay. In this environment provided from a bigger module, because as I said, the module emits signals only in this environment, which doesn't include all the modules. When one module connects to the central module, it gets one event module object, and all the signals which it emits actually are spread across only this environment, not the entire environment. And if there is somebody listening there, the signals would be heard and somebody would react. In this case, when this environment is sent to the new module, actually who is listening is maybe only the central module, and this central module could react on the signal emitted by a module, and after that it could forward this signal to the central environment, central event manager if you want to call it this way, or could do something else if this central system is more intelligent. Okay, each module can listen for an event. Of course, maybe there is no module which is emitting signals, which is not triggered such event, but this is not gonna break the system. The most important is that this architecture will not break if somebody is listening for an event but nobody is emitting, nobody is triggering this event, or vice versa. I like to think about the application also like electronic circuits. This is another analogy. This is exactly what the event manager is. These sockets. These sockets are the physical interface which allows us to connect different modules. In this socket, for example, we can put a graphic card which is Radeon, for example, ATI, or GeForce, whatever, but both of them will work. Some of them may use some of the signals, another not, but this doesn't change anything. The graphic card continues working. The same with this socket. So this is another event manager. We can put here AMD processor or Intel processor, but the motherboard probably will continue work, if of course the motherboard supports both processors. Usually they don't support both type of processors, but let's say AMD one version and AMD other version. As far as the sockets are the same, different processors will work, different CPUs will work. Okay, so this is how I think about the application and the event manager. So the most important thing about the event manager is that event manager could be called differently. Event manager is an environment which allows us to transmit signals back and forth between two parties or many parties. It doesn't matter, depends if this environment is given to many modules. to many parts of the application and they share the same environment, they can communicate. Even if they don't share the same environment, they still can communicate through a proxies. Okay, this is what I wanted to say about the structure of the application. I like to think this way, and I like to build my applications this way. Actually, I have built one application exactly the way I describe it. I don't call the object which I instantiate and send to the modules in Event Manager, but the name is not that important in this case. The important thing is the idea of having one object representing the environment for sending and receiving signals. And the application works actually very well. It's a JavaScript application. So each time I create a module, I instantiate one object which I called connection, and I send this connection as a parameter to the new instantiated class, for example, or a module. So I'm sure that whoever instantiated this object or module or built the module and sent the environment object can communicate through this environment object with this module. And if I like, I can give this module, this environment actually, to another module. So I will allow direct connection between two modules if I do that. If not, if I wanna keep the things centralized, then the central module, when it instantiates other modules, when it creates other modules or attaching other modules, always sends a separate instance of the same class, separate environment, which allows the two modules, the central module and the new module, to communicate. And the central can play the role of the proxy, if this is what we want. In the physical world, actually, because we always talk about interfaces in the applications, so I want to clear this a little bit, just to say what I understand about when we speak about interface. Interface in the real world has three levels: physical, electrical, and logical. I have to move this way. Physical. So in order to communicate, the devices, the entities, should share common interface which allows them to connect to each other. For example, the motherboard has these sockets, and the graphic card should look the way which allows the graphic card to be plugged here. This is a physical interface. Electrical interface. Electrical interface means that the levels of the electrical signals should be compatible. For example, my graphic card should expect voltage not higher than 3.3 volts, for example. It cannot expect 2000 volts. This is electrical level. And the third level is the logical level. On the logical level, the both devices should understand each other. There should be a negotiation, there should be a conversation which both devices, there should be a language which both devices speak. Okay, in the software it's much easier. In the software, in the interfaces, what we do is only define different functions, methods actually, and this is how we fulfill the interface. Okay, let's talk about the events. Event is something that does happen. Actually, Matthew from the Zend framework team has a very good webinar about the events, and he's talking about in details about the event manager and how it's implemented in Zend framework too. I have built the application which I was talking about years before, 2-3 years before actually we started to speak about Zen Framework 2 and all these things. Just because I have been forced by the circumstances, I had to build a very complex application on JavaScript. So I came to these ideas before we start talking about them in Zen Framework. But I couldn't agree more than what we have in Zen Framework 2 right now is the right way to do things. Now, this will allow us to decouple all the elements of our applications. And I even think that this is more important than the service manager which we have, and the dependency injection and service locator. That's also important, but as I said, the event manager and widely use of the event manager in the framework, in the Zen Framework 2, actually is more important to me. Listener. What is a listener? A callback responds to an event. So we have two things. We have events and we have listeners which are listening for these events. Also, I have to mention some terms. Usually in different languages, in different circles, I have heard terms like trigger, attach. This is about Zen. Those are the two counterparties of the event mechanism, trigger, attach. This is how they call it in Zen. In Dojo, for example, we have a public subscribe. In other systems, notify, listen, but we're talking about the same thing. Also, when we actually trigger an event, we usually send the context. So the context also is called a target. In Doom 3, for example, document object model, when one event is triggered, as a part of the event object we always have the target who actually triggered this event. So this target is also called context. I want to mention these terms because we're using a lot of terms and most of them mean the same thing, but we get confused because we are not sure. When we talk about the event manager, my associations are, I would call it environment for signals, wires, channels, connection, and bus. Those are other associations which this word event manager actually makes me think, makes me do other associations. Event manager, how to attach and call back listener. Okay, so back on the ground, a little bit more real life example which probably everybody would understand. So sorry about the fact that indents are not correct. As I said here in the notes of MindMeister, I'm losing my indents, so it's a little bit hard to understand the code like that. But this is a good example which showing us if we don't care about how our code would look like, how ugly the things can get. So we start with use Zen event manager, we instantiate the event manager, use a callback, an anonymous function, or known also as closure. Events, attach the name of the event, do. So this function actually is gonna listen. We are attaching right now one listener to event called do. We can call it also channel or whatever you like. So let's stick with only one term, which is the name of the event. So this event is called do. And what we are gonna do, function, and this function always receives only one argument, so we have only one parameter, event. And in Zend Framework 2 we have a standard interface about the event object. In this interface we have to define, it's defined actually the function getName. So we can get the name of the event and we can get the parameters. Oops, I made a mistake here. I will correct this. Get params. So let me do that immediately. So whoever actually triggers an event can send the content, can say of course what event, can say the name of the event, we'll see just shortly, the name of the event, can send the context, and can send parameters. And this is how we trigger. So once we attach an event listener to an event which is called do, this is how we call it. Again, use the event manager instance events, and we say trigger do, context in this case is null, and we say the parameters, we send the parameters. In this case it is an array. Perfect. So this is how the connection is done. This is how we can communicate actually between one part of the application where we trigger the event and another part where we have the listener. So Matthew was talking about the event manager as a collection of listeners and triggers events, what the event manager does. Yes, this is exactly what the event manager actually does. We can think of the event manager this way. Priority. We can assign a priority when we attach the event listeners. The priority determines which event listener to be executed first when the event is triggered. As a third parameter, we can send the priority. The low number, the low priority. The high number, the high priority. So this event listener will be executed first. The default priority is 1 if we don't mention the priority. How to trigger? We saw already how to trigger, but explicitly. Let's say we're in a function, in a method, somewhere in a class. How we trigger an event is we instantiate actually events. Somehow we have to get the event object, and we say trigger name of the event, this, the context, params. I probably have to add here brackets, round brackets, because it could be an function which returns actually the event object, the environment which allows me to communicate. This is how we trigger. Listeners. I'm using an anonymous function here, and I put this example here just to show you some of the functions some of the methods which we can use on the standard event object. So we can say get name, and it's gonna return in our previous cases, for example, do, because this was the name of the event. We can say get target and get the context or the target. It's an object. And we say get params. If you need more, you just have to refer to the Zend Framework 2 documentation. I mean, if you need to see more standard methods which are coming from the interface. The most important is that the listener receives receives only one argument, and the listener could be any valid PHP callback. Recommendations. Some of the recommendations are, when we trigger an event, to send the name of the function as the name of the event. After that, to send the object in which context is we are executing this trigger method, and to send as parameters the parameters sent to the function. Those are the recommendations. Of course, as a parameters we can send whatever we like. Function dot notation. So if we need to send more than one, if we need to trigger more than one event in a method, then we can use a dot notation, which means the name of the function dot and something, which is clear enough. For example, from the dispatcher in Zen framework, dispatch dot pre-dispatch. Pass all input as a parameter. I told you already that. Global events. So what the global events are, and we can create such object in Zen framework too, is an environment which allows us to communicate different modules to communicate on a global scale. For example, if we look at again this picture, with a global event, what we create is environment here around all modules, which allows them to communicate directly. I would search for another analogy, for example air. So by creating a global event manager, we are creating an air which allows us to verbally communicate between each other. We don't need to touch each other to communicate different messages. If there is a air, a global event manager, we create environment which allows us all the modules to only listen. In this case in Zen Framework 2, actually we only can listen for the signal coming from the center, or in another architecture we can allow the modules to communicate directly through this environment. Okay, and how that could be done and how it's done in Zend actually. Here it is. One example. Use Zend Event Manager static event manager. Correcting this. Events static event manager get instance. This is how we get access. It's a singleton. This is how we access the global event manager. Events attach, context, event, callback. The context usually is the name of the class, the event is the name of the method, and this is the callback which listens for this event. I already discussed the terms, so those are the ideas which I wanted to share with you today. Thank you for your attention. See you next time. Bye for now.